Okay guys, welcome to even and odd functions. We're going to continue talking about functions and relations. And so this time we're actually just looking at a neat little couple properties on what it means to be an even or an odd function. In here you'll hear some things about symmetry. We'll hold off on symmetry until another lesson. Even function, okay? And I want you to be very specific. Just because a function has an even power doesn't make it an even function, okay? Then that's a big mistake. So an even function, algebraically what you have to show is that your function is equal to f of negative x for all x's in the domain. This would also mean that you have y-axis symmetry, okay? And then taking this idea, for every point xy on the graph, negative xy is also on the graph. And we had a little bit of erasure here. Okay? So you want to be very careful with how you say that. So when you say f of negative x, it's a really good idea to look at these ordered pairs here. xy is on your graph and negative x comma y is on the graph. Okay? Okay, so the second odd function must show that f of negative x equals the opposite of f of x for all x in the domain. We say this has origin symmetry, okay? Origin symmetry. So what that means, if xy is on the graph, negative x, negative y is also on that graph. And we'll be able to visually see this. So we're talking about even and odd functions. Even, you must show f of x equals f of negative x. It's y-axis symmetry, and here's the big key. If you have x, y are all on your graph, negative x, y has to be on your graph. In odd functions, we're showing f of negative x is equal to the opposite of f of x. It's origin symmetry, and x, y would, and negative x, negative y would be on the graph. Okay? One thing before we move on, let's look at this idea of when we have x, y, and like negative x comma y. For even functions, the y value of the function at any given distance to the left of the y-axis is the same distance as the y value at the same distance to the right of that axis. Meaning, if I'm negative 3 units to the left and 4 units up, if I go from the y-axis 3 to the right, I better be 4 units up and have that matching point. Really good even function, easy to see, is think of a parabola. Same distance on both sides, or absolute value of x. Those are both symmetric to the y-axis and even functions. Okay, odd function here, the y value of the function at any given distance to the left of the y-axis is opposite of the y value at the same distance to the right of the axes. And so these are going to be hard to look at or write down and say, oh, I get this. Let's look at what each of these mean visually. Okay? On the left here, I have an even function, and on the right, I have an odd function. And so what that even function says, if I pick a distance that's x or y units away, so if I pick this distance here, right there, this is negative 2, 0. Okay? Now, I am 2 units away from the y-axis, and my y value is 0. In order to have even function, I would have to go 2 to the right, and my y value would still be 0, and it is. Let's look here. This is negative 3, negative 1. So 3 units away on the left from the y-axis, and down 1 I have a point. So there better be a point 3 units to the right, and 1 down as well. So that's the idea. We're showing that f of 3 equals negative 1, and we're also showing that f of negative 3 equals negative 1. That's the idea. F of x and f of negative x are the same, and it's the same throughout. And the idea is if you folded this graph over the y-axis, you would have the same, the graph would lie on top of one another. That's a way you can check too for symmetry. Fold that over. Odd symmetry is a little bit different. Remember, we had the y value, and if the y value was x units away and y up, the other point would have to be the opposite. So think about odd symmetry. We said that if y is on the graph, that means negative x, negative y is on the graph. So here's the idea. If we have 1, 2 being on, negative 1, 2 being on the graph, negative 1, 2 is on the graph, that means 1, negative 2 should be on the graph. So if negative 1, 2 is on our graph, that means 1, negative 2 should be on our graph, which it is right there. If we have 2 comma negative 3 on our graph, if this is an odd function with origin symmetry, that means negative 2, positive 3 should be on the graph. Negative 2, positive 3 is there. And you can see that this graph is an odd function in its origin symmetry. So that's what we mean by the last slide with the wording, okay? But it's easier to see visually. Okay, so let's look at algebraically how we can show functions are even and odd. Now I want you to realize, usually students find it very helpful to look at a graph when determining whether a function's even or odd. It's very easy to see. The equations are a little bit harder. So let's determine if the following 4 functions, what kind of symmetry they have. Now I want 2 things to realize. Just because it's an even power doesn't make it even. Just because you have an odd power doesn't make it odd. Okay? And same thing, if it's not an even function, it doesn't automatically make it an odd function. So let's look. So here's our first function, f of x equals x squared minus 3. Okay? Now visually I think of x squared, that's even, and I just shift the graph down 3 units. Mathematically or visually, hopefully you can see that this is going to be even. But let's check it out algebraically. So here's my original function. Now in order for a function to be even, and I always test that first, I have to show f of negative x is equal to the original. So let's look. So f of negative x equals, and wherever there's an x, I plug in negative x. Negative x squared minus 3. Doesn't matter what's inside here, you're always squaring it, you're always going to be a positive number. So you get x squared minus 3. And notice how here and here are equal. F of x equals f of negative x. So we would say that function is even. All right, lots going on here on the second one, and it looks like we got a little bit of a, there we go, plus. Little smear there, apologize for that. So, in part B, I'm seeing a cubic, 2x cubed plus x. So, I think odd, 3 is odd, so I think, well, why not try odd symmetry? Okay, so let's, or odd, see if it's an odd function. So I need to look at 2 things. I need to look at f of negative x, and I also need to look at the opposite of f of x. So I got to show 2 things, that show 2 things are equal. So f of negative x, I plug in negative x wherever I see an x, and so I get negative 2x cubed minus x. You can see that's not equal to the original. These 2 are not equal, so the function's not even. Secondly, I take the opposite of the function and see what I get. The opposite of this whole function is negative 2x cubed minus x. And now we've seen that, look, those 2 functions are even, so this function, f of negative x equals the opposite of f of x. So this function is an odd function, okay? So all you're really doing here is substituting a new value in for x, okay? It's either going to make x opposite, or you're taking the opposite of the entire function, okay? Let's look at part C. Part C, you have f of x equals x squared plus or minus 2x. Okay, so you might say, oh, even power, this is an even function. Well, let's check it out. So I'm going to check the even function first because the power is even. So f of negative x is equal to, you guessed it, wherever there's an x now, replace it with negative x, and I do that here, and simplify. You square a negative number, it's always positive, doesn't matter. And then subtracting negative 2x makes it positive 2x. So notice how these functions are not equal. The function is not even. Okay? Let's just see if it's odd. So I've already found f of negative x. Let's find the opposite of f of x. So I go ahead and do that, and you can see right away the opposite of x squared is negative x squared. That's not going to work out. I mean, their term here is negative x squared. So this function is not odd. This function is neither even nor odd. And lastly, again, we got the boards must have. Okay, sorry about that. Okay, so we have f of negative x, or f of x equals x over x squared minus 1. Okay, I'm going to test, I'm just going to find f of negative x and the opposite. I'm just going to get both of these and see if either one of them pops up as equal. So when I look at f of negative x, I plug in negative x everywhere for x, and you can see the numerator has changed. So this function's not even. You can tell because these two functions are not the same. So you could say not even. Okay? Now let's look across. You take the opposite of your function. Now this is where it can get tricky. Now the opposite, I could put the opposite out here, and you'd say, all right, well that's good. So where does the negative go? Well, the negative can go on the top, the negative can go in the denominator, or the negative could stay out front. Well, if I put the negative in top, and that's what I had written before, guess what I get? I get two functions that are equal, f of negative x and the opposite of f of x. This function is odd. Okay? So that's even and odd functions, and we're going to work more in class with that, and we're going to get into symmetry. If you guys have any questions or comments, please email me below, or email me. You can type them below the comments, or you can email me at nicholas.bennett@dc.gov. We'll see you next time.